If you want to find the radians in quadrant 2, then we say, okay, let's start back right here at 60 degrees. So we kind of come back a spot, and we say 3 minus 1 is 2. Put the word pi, or put the symbol of pi, and then divide by. Over here, we say, okay, we come back to here. 4 minus 1 is 3. Put the pi, divided by 4.
Oh, I get it.
Over here, 6 minus 1 is 5. Put the pi, divide by 6. 180 is just pi. That's just the conversion. And then down here, we say 6 plus 1, 7 pi over 6. 4 plus 1, 5 pi over 4. 3 plus 1, 4 pi over 3, and so on. So, questions? All right, we also need to, this is the big thing to remember, that the x values represent cosine of theta, and the y values represent sine of theta. Got to know that. X values represent cosine of theta, y values represent sine of theta.
It's just like in physics.
In physics?
Mm-hmm.
Yeah.
Oh, really?
Yeah. Total initial, total.
Oh, good, good, good. Now, there are a few things I want to recognize about what are happening. So the first thing is in quadrant 1, remember this is quadrant 1, Q1 right here. In quadrant 1, I notice that the sine of theta is greater than 0. Why? Because the y values in quadrant 1 are always greater than 0. Cosine of theta is also greater than 0 in quadrant 1. Why? Because x values are always bigger than 0 in quadrant 1. I hope people are writing this down. If you're not, and then you don't do well in this class, don't be surprised why. In quadrant 2, x is always bigger than 0 in quadrant 1. So therefore, cosine is always bigger than 0 in quadrant 1. In Q2, that's over here. In Q2, well, cosine, which are x's, must be less than 0 over here. So in Q2, cosine of theta is less than 0. And sine of theta is greater than 0. Y values are above 0 over here. You guys on your own do Q3 and Q4. I'll be doing it on the board. I can do it over here. And there we have it. Please verify that you're getting that for Q3 and Q4. Please verify you're getting that. The next piece I want to discuss, is what is actually happening within quadrant 1. So if I look within quadrant 1, so now I'm talking about, let me just look right here. Within quadrant 1, let's see what happens. Well, I notice that the cosine starts at 1 and goes to 0. The cosine starts at 1 and goes to 0. So I would write that in quadrant 1, cosine of theta is decreasing. It is getting smaller. The cosine starts at 1 and gets smaller to 0. Sine of theta in quadrant 1 starts at 0 and goes up to 1. So sine of theta is increasing. Questions on that piece? Jasmine?
Can you just say it one more time?
Which one? Both?
Yes.
So the cosine starts at 1 and gets smaller, smaller, smaller until it gets to 0. So the cosine value is decreasing. Does that work, Jasmine? Whereas sine starts at 0, is getting bigger, and goes up to 1. Let's see what happens in Q2. Cosine starts at 0 and goes to -1. So it's getting smaller. -1 is smaller than 0. So I'm going to say cosine theta is decreasing. This will be really helpful on Friday when we draw the graphs of sine and cosine. Sine theta, what is happening? We start at 1 and we go down to 0. Decreasing. Sine theta is decreasing. Try quadrants 3 and 4 on your own, or you can ask the questions if you have some on quadrants 1 and 2. All right, so I'll go ahead and do Q3 on the board. Check your work up here. Q3 is up on the board. Q3 is up on the board. And let me end by doing Q4.
Quadrant 1? Wait, why is quadrant 1 goes decreasing?
Because the axis.
All right, so here's what we have for all the quadrants. Let me stop here and take some questions.
Oh no, it goes this way.
Jenny.
Never mind. It increases from this.
Okay. Right.
Oh.
Yep. Marvin?
The cosine for quadrant 2 has to decrease.
For which quadrant?
Quadrant 2.
Quadrant 2. So the cosine starts at 0 and goes to -1.
I think you always starts on the left. Or is it just by angle?
No, yeah, it's by angles, right? So here's the beginning of quadrant 2. Here's the end of quadrant 2. Yeah, good point. Good question. Any more questions on this? All right, let's push forward. So why is the unit circle so useful? Well, because it allows us to solve. If you look at the homework that is due on Monday, page 1 of the homework due Monday. So look at page 1 of the homework due Monday. Problem 1 says, what is the sine? We need to move it here. I think we probably do. We don't even need to pause it though. Let's just pick it up and move it. So problem 1 says this. Sine of 360 degrees.